interested and you want to learn more and go more into depth about CyVerse, just go to cyverse.org and you will find all kinds of learning materials and information there. I will, however, start with a quick introduction. Oh, that's not where I want to take you. Let me actually get my, sorry I didn't have my slides up and sharing my screen to start with. Let me get that started. There we go. Okay. Okay, hopefully that's showing up okay on your end as well. Okay, so the focus of the webinar today is really going to be about managing large collaborative data sets for easier storage, analysis, and discovery, particularly doing that on CyVerse, but I'm going to touch on a lot of general principles that are independent of CyVerse. So I will start with a very brief introduction to CyVerse. As I said, if you want to learn more, please go to cyverse.org or learning.cyverse.org. Then I'm going to talk about what are fair data and why you should make your data fair. And then I'm going to cover some CyVerse tools that you can use to help create fair data. And then by the end of the webinar, if you're following along, you should be able to do some really basic tasks on CyVerse, including uploading a file, sharing a file with a colleague, and adding metadata to a file. And I'm just going to see if I can't, sorry, I'm going to see if I can't. I want to be able to have the chat. I just want to make the chat window open, so in case someone's asking questions. So stop the presentation for 1 second and have any, okay. So that way I've got the chat window open in case someone wants to ask a question while we're going. Picking back up with the presentation. Okay, so CyVerse is the NSF, National Science, U.S. National Science Foundation funded cyber infrastructure for life sciences, though we obviously support a much broader community than just life scientists. Our vision is transforming science through data-driven discovery, and our mission is to design, develop, deploy, and expand a national cyber infrastructure for life sciences research and train scientists in its use. We currently have more than 50,000 users. In fact, I think we're over 60,000 users. We have petabytes of data, approaching 5 petabytes at this point, stored on our data store. And there have been hundreds of publications and courses at all levels and discoveries that have used CyVerse infrastructure. We like to think of CyVerse as the Lego building blocks of cyber infrastructure. So Lego comes from the Danish leg godt, which means play well, but it can also translate into I put together. And we think of our infrastructure as sort of modular with lots of different pieces that we've put together into certain kits. You know, we've got sort of like pre-built things that you can use, but if they don't serve the needs, you can put those components together in a way that suits them for you. And we here at CyVerse as a staff are here to help you do that. This is just a real high-level overview of our infrastructure. So we call it our layer cake with hardware resources on the bottom of the bottom layer, some low-level basic computational services like iRODS, which is our data storage, authentication, connection to the National Supercomputing Center. And those 2 layers really form the foundation of our infrastructure. On top of that, we have a number of services that access those foundations, like our data store, different APIs, Elasticsearch, etc. And then on the top are our user-facing products. These include the discovery environment, which I'll be going over, I'll be demonstrating today, but also platforms like Atmosphere, which is free cloud computing for sciences, and the BISC image analysis system. So that's it. That's all I'm going to introduce for CyVerse today, but I'm going to move right into the topic, which is data. So what are fair data? I don't know how many of you have heard of fair data, but if you're going to a number of, if like me, you go to data management or infrastructure conferences, this word has been repeated at talks over and over again for the past 2 years. So when we think about fair, we think about sharing data. It's often like this, we have 2 scientists who are working together and like, well, I need this block, so okay, let me give it to you. And you can just take it and it's really easy. But the reality of data sharing is actually often more like this. No, I know it's not the scientists don't want to give their data up per se. In fact, most scientists are happy to share their data where appropriate. But there are many restrictions on making it easy for them to do so. Not so much sibling rivalry, but often technical limitations to sharing their data. And even just the ability to discover and find the data that they want to work with can be really challenging. So what the FAIR principles are, and you can read more about it in this link to the paper that came out, I think in 2016. FAIR stands for Findable, Accessible, Interoperable, and Reusable. So the goal is that when you publish a scientific study and you created data that goes along with that study, rather than just saying, well, I published my paper, I'm done with it. Ideally, for reproducibility, you should take all of the data that was used in that study and try to make it as fair as possible. And so why would you want to do that? It probably sounds like, well, it's just going to create more work for me. Why would I do that? Well, you've got different kinds of motivation, both the carrot and the stick. So many of the steps that you can use, and I'm going to be talking about later in the webinar, to make your data fair are also going to make your life easier. Basically, using good data management practices helps make the data fair, and it should make your life as a scientist, as a researcher, easier. Making your data fair can improve your reputation. Now, it's true that there are different cultures within different branches of science about the value of publishing data as opposed to just publishing scientific papers. But I would say that overall the culture is changing, and there is a recognition of the value of publishing data sets. So you can definitely have some credit for your academic output by publishing your data, and not just the results that come from that. Of course, if you're getting funding from any of the national funders or international groups, most funders now require that you make your data public and accessible. And in fact, they explicitly mention FAIR in many of the NSF funding announcements. I'm not familiar with that much with other agencies, but they probably are similar. So you kind of have to do it. That's kind of the stick approach. But also as a scientist, if you're interested in practicing reproducible science, it's really difficult to reproduce your results if people can't see your data. So that's another good reason to make it fair. And finally, I appeal to altruism. Most of us as researchers, I think, actually do want to make a positive difference in the world. And so making our data publicly available and findable, accessible, interoperable, and reusable does support that common good. So hopefully that's a good carrot type motivation.
Ramona, can
Yes?
I stop you for a minute?
Sure.
We're not able to see your primary slide. We're seeing the two slides.
Oh, no, really? Let's see. Let me do, how about if I just, instead of using the slideshow, I just make this the full screen?
Let's try that.
And
Maybe take off the
sidebar.
Yeah.
And zoom out as much as I can. How's that?
There we go.
Okay, sorry about that. So you missed my my fun illustrations of children playing nicely with blocks and then children fighting over toys, which was what I was talking about in the previous in my previous discussion. For those of you who are watching this later and you're like, what the heck is she talking about? That's what those slides were. So let's see if I can make this work. Okay, there we go. Okay, so, but I won't go back to them. You'll get these slides later and you can review those if you'd like. So I'm not gonna go into great details about what it means to be fair. And if you're really interested, please go read the paper. It's a very short and quick read. So, but just to quickly sort of highlight, what does it mean to be findable? You need to have good metadata. And those metadata have to be registered in an index and searchable. That's the bottom line. If to be accessible means that you have to have a protocol that someone can access the data. You know, it shouldn't be sitting on a hard drive on someone's computer. Sorry, it's not a hard. It shouldn't be sitting on a hard drive that's on somebody's desk that's not connected to the internet, for example. So kind of basic stuff. To be interoperable, again, metadata is really key because the metadata is what explains to other people what your data mean. And to be reusable, look, that word metadata comes up again. So in order, again, for someone to be able to reuse their data, they need to understand it. And so having metadata that's consistent with the relevant community standards is really important. So metadata, 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 that's the answer. And I'm going to be talking to you throughout the rest of the talk about why and how you can use metadata. So what can you do to make your data fair, other than using metadata, of course? So I think one of the first steps really is to understand the data lifecycle. There's a couple of animations in here that said this will make a little bit less sense from this view, but it doesn't really matter. So this is one simple illustration of the data lifecycle. There are more complicated ones with more steps, but you know, think about a sort of typical workload flow for a scientist. You might have some planning in here, you've got data generation, you analyze your data, and then you publication. And I think that's about what many scientists kind of think of as the data life cycle, as it were. But in fact, it's not just a life line, it is a cycle, it does continue. So after publication, data can be discovered by others and then reused, which can lead to the generation of new data. And why is this important to you as a researcher who's possibly only generating or analyzing data? Well, if you're going to make your data fair, you need to think about what you should be doing at these earlier stages in the life of your data in order to support the later stages. So when you're generating data, if you know you want to support discovery later in the process, then you might think, okay, as I generate this, I'm going to write down the relevant parameters. I mean, this is something we're trained to do as scientists anyway. So write them down in a way that they're going to be associated to the data and discoverable and part of that data. Same with an analysis, store your analysis outputs in formats that are openly accessible. Store them in CSV files rather than Excel files, for example. Of course, the cycle doesn't always go exactly like this. There can be errors going every which way here. And I think one of the most common ways of shortcutting this cycle is to go directly from analysis to discovery, in the sense that before we publish our results, we might actually have a large data set and we want to go back and look at it and find it and analyze it in different ways and do new things with it and reanalyze it eventually. And so it turns out that, in fact, the person who most likely will need to discover your data and reuse it is yourself. So making your data fair, this is another way in which it really does help you and make your own life a little bit easier. Excuse me, let's take a sip of water. Another way to help produce fair data is to learn about data management, especially working on very large collaborative projects. Data management plans are essential. Here are two different, here's an article and a tool for how to write a good data management plan, 10 simple rules. Like I said, I'll share this presentation so you'll get the link. If you do use spreadsheets in your research, everybody does, I do too. Everyone's heard about the horrors of Excel and what they can do for data, but Excel is an incredibly useful tool. And even if you use OpenOffice, it still has some problems. So just have a quick look at this paper, and it can help you use spreadsheets in a way that will help help eliminate future problems. If you would like to learn more about some data management tools, Data Carpentry is a really useful organization. It's sort of a spin-off of Software Carpentry, if you've heard of that. So they provide a number of lessons on working with data and managing data. Data One is also a really great resource. They've got this whole part of their website that deals with best practices for data management. Data One is a large aggregator of earth sciences data. So these were written, these are the resources that I'm familiar with as a life scientist, but I think that all of these would still apply very much to astronomy or physics or other types of sciences. And so again, and here's just one more, a really nice article on best practices for scientific computing. So if you're new to the field of using computational tools to do your science, then I would highly recommend checking out this article. It's a really great thing full of tips. And even if you're not new, if you're experienced, it will probably provide some hints that you're not familiar with. And then coming back to my favorite recommendation for making your data fair, use metadata. So hopefully many of you have actually heard the term metadata, and you're at least vaguely familiar with it, what it is. But basically, if your data is a picture, like this picture of a cat, then the metadata is all of the information about the picture. So metadata is data about the data. In the case of images, you might have metadata of the things like the author, the file name, what type of camera was used, what lens was used, the exposure, etc. And then geographic metadata is also really important. Most cameras now, in fact, automatically capture the location in which an image was taken. So that's really easy. But if you're not using a camera that captures metadata automatically, then it can be more challenging. You need other methods to record and preserve that metadata. Excuse me. And then finally, following best practices for data organization is really important. So as I'm going to talk about more in the second half of this folder, and file naming conventions are really useful. And in fact, I use them. Every scientist I know, their favorite form of organizing and managing their data and metadata is through naming conventions and folder hierarchies. And they do work in many situations, but they're really restrictive. If you as I'll show you later, if you use metadata instead of just file names, you can actually do have a lot more power to do more interesting and useful things with your data. Avoiding unnecessarily deep hierarchies. That may sound trivial, but as you're trying to work with data, having 7 layers of folders just to get to the data, it gets to be really annoying as you're working with it, especially when you're trying to script it and you've got to write these long file paths in there. And it's a really restrictive way of organizing your data. So you try to avoid that as much as possible. Writing down the rules for organizing and naming data. This is like a really the most fundamental thing for data management. And if you're all working on, I think many of you listening to this are going to be working on this large collaborative project. Even when it's just one person, but especially when it's multiple people working on a project, if you don't write down somewhere what you agree to do and how you agree to name and organize your data, someone will forget and people will make mistakes. And so having it written down in a publicly or at least group accessible document is really important. Having strategies for version control, also really important. Forking is a huge problem, especially when dealing with big data, because for very large data sets, it's not always that easy to just store every version of the data set. It doesn't become practical, and you can't just put it on something like GitHub, which you could use for code. So you need to have a well worked out strategy for that version control beforehand, and so know when someone else makes a new version, what version are you using, what did they do to it. Really, really important to write that stuff down. Very basic stuff, avoiding special characters and spaces in your names. And so I think many of you probably work on the command line, so you already would understand why that's important. And these tips come from this really nice short guide online from the University of Pennsylvania on data organization. So, and finally, the last piece of advice in terms of making your data fair is to practice reproducible science. So recording metadata at the same time you collect the data, not when you're ready to publish it. So I think probably most scientists, in fact, do this. As I said, we have a lab notebook or we have a document if we're using a laboratory information management system. Whatever method we have, we know that we need to record what we're doing when we're doing it. But then we don't keep that with the file as the file moves through subsequent steps. So keeping track of that metadata and keeping track of your workflows and the provenance of data as it moves through a workflow is really important for reproducibility. And that's one of the things that we work very hard with. I'm not going to talk about in this webinar, but at CyVerse, because we are a cloud platform for doing your analyses, we do automatically track all of the steps that your data has gone through, so the provenance is tracked somewhat automatically. And there are a number of new tools for doing that as well. Creating a data dictionary if needed. So a data dictionary is simply a list of what all of if you have tables of data, it's like what all the column headers are and what they mean. I can show you an example of some data from the PIRE-EHT project where I have no idea what it is. Probably maybe many of you do, but it would be really useful to have a data dictionary to help explain that. Already mentioned non-proprietary data formats and publishing your data in an open repository. I know that a lot of the PIRE data may not be at the point where you're ready to publish it yet, but when that time does come, putting it up on your server at your own institution is not an open repository. It doesn't have a permanent identifier. It doesn't have standardized metadata. It's not going to necessarily have does not necessarily have a standard access protocol. And so working with a trusted and open repository is really the best way to make sure that your data is out there and fair and available for reproducibility. So I'm going to take a quick break here, have a drink of water, and go through a quick example from the PIRE project that CK was nice enough to share with me some of the data. So there's some simulation data, some of them that are backed up on the CyVerse Data Store right now. And I have to say, I'm really happy to see the effort that went into organizing it. So it's got a consistent layout. You've got these README documents that actually explain the way that the data is and what is usable. You've got your reuse conditions right up here in the front so that people can see them, which is really great. You've got an explanation of the library structure. However, there are definitely things that could be improved about this data management. And I'm not here to give a full critique of it, but I'm just going to point out some things that I think could make life a little bit easier if they were done a little bit differently. So one of the challenges you see, I just highlighted this line in the file that says, at the file level, there are many possible naming conventions, right? And so right now there's one of them being used, but there's other ones. So which one are you going to follow? And if this naming convention is the only source of information for what a piece of data has N1, N2, and N3, I assume that these, I know these are numbers, and I have no idea what they mean. I'm not an astronomer, but if that's the only, if that file name is the only place where the values for N1, N2, and N3 are stored, and different people do it differently, and it's not written anywhere what they mean, that data is essentially meaningless to anyone outside the project, and probably even to most people within the project in 5 years, because it will almost certainly be forgotten. So again, it works great in the short term and for small data sets, but in the long term, it can become really problematic. So let me just go down here to, I've got a couple of links that I can't click on directly because of the way that we're presenting, unfortunately. So I have to go get out of here. Oh. No. I can't stop viewing the full screen. Sorry about that. Doesn't help. My normal keystrokes don't seem to be working, so I think what I need to see is hidden. Well, it doesn't matter. Okay, we don't really need to go. So I was going to go and look at the full file in the directory, but that's fine. So I think I have what I wanted to show you really was this description of the library structure. So there's, in addition to this, this is the catalog.txt file right here that I'm looking at. And again, like I said, it's great that it explains this, what's going on with the data. So that's really useful. The next, this other link to the library structure.txt takes you to a file that explains the structure of the folder hierarchy. And I've just copied a little, this is not from that file, this is actually just a representation of the actual hierarchy that you've got. So about 3 layers deep in the data set, there's a folder called Backup Simulation Library, and then it has subdirectories which include MAD and SANE, and I assume that people in your project know what that means, but obviously I have no idea, and so as someone who's coming here looking at this data, it's not helpful to me at all. I mean, I'm a biologist, like, hey, you know, this could be useful, but I can't even tell that it's necessarily astronomy data based on these kinds of names. And so then within that, within the MAD and the SANE, there are subdirectories named with the A+, and these are parallel hierarchies. So you have A plus 0.25, 0.05, 0.075, etc. Again, I don't know what that means, but it's probably useful. And then I think this was here we have the naming convention of the N1 times N2 times N3, and 2 slightly different measurements here, but similar. And then under both of those, there's folders called dumps. And then there's a file called dumps 00000.h5, which is the same in both of them. And so, so we have to get down about 6 levels. I'm not showing some of the upper level hierarchies. So I've got to go down like 6 or 7 layers just to get to where the data is. And ultimately, it's organized under dumps, images, and one other directory, which I don't remember the name of. And so that's probably really useful for the person who set it up, because they're always going to want to access their data based on dump. But suppose that they wanted to access all of the files that were from the same A+ level, but from MAD and SANE. I mean, so basically think of it this way. You've got your data set up in a single hierarchy, and so the files are grouped in one way, and there's no way to ever group them any other way. What if I want to pull one file from each of the directories? That I've got to little manually go in and do that, or write a script that will do it. And that can be very tedious at best. When you get into projects with thousands of files, it actually becomes almost impossible. And we've worked with many projects where this is the case, where someone comes in and says, hey, I've organized my data in a hierarchy where A is the first level, and then B, and then C, and then D, and then E. But now I need to subset it based on B, based on D, and then sorting by B. And I can't resort it without having to create a whole new folder hierarchy and new system. And it becomes a bit of a nightmare. So again, even though when you're doing the project, you probably just have one way that you need to do it, chances are that in the future, you will need to reorganize your data. Or again, once you've published it, someone else is going to want to use it in a different way. So it's really nice. There's nothing wrong with having it in the hierarchy, but at least having, if you have metadata on it, that makes it possible for people to go back and subset it in the way they want. So think about it this way. Whether you have it in a very structured hierarchy or just a single level, like one folder with all the data there, which is not what I'm suggesting either, imagine that every single file, all of those dumps underscore 000 whatever, had metadata that explained that they were from 192 by 96 underscore iharm. And they were also from A plus 0.025, and also from MAD, and also from the backup simulation library. And then I could do a query on any of those levels and basically aggregate the data in the way that I wanted. So that provides much more flexibility, much more discoverability, and ease of reuse. And so that's, for me, really one of the key values that you can get from having metadata associated with your individual level data files, is that ability to search for and subset them in the way that you want for whatever needs you want, not just for the single need in which they were originally organized. So that's my soapbox. I hope that makes some sense to you and is useful. If it doesn't make sense to you, if you have other use cases and you want to talk about that to me, please reach out to me after the webinar. I'm happy to talk about this more or answer any questions about it. Okay, so. That said, now that I'm stepping off the soapbox, I'm going to go down now into some actual basic tools that you can use in CyVerse to do some of this stuff. So now I really do need to get out of my, let me just do this, out of this view so that I can use the web browser to do some excuse me, I'm sorry for this delay. I'm just this is embarrassing, but I don't actually know how to get out of the full screen view in Excel.
Yeah, I actually think Microsoft Office has some bug on Mac. So maybe the only way is to click the PowerPoint and then reopen it.
Yeah, okay, I will do that. Thank you. That's kind of embarrassing, but I'm sure I've done it before. I've done this many times in my life, and it was obvious. And now I'm not sure why it's so difficult this time. It's something I have updated my PowerPoint, my Microsoft Office rate lately, so maybe it's just a different thing. Okay, so we'll just keep this at a slightly smaller view that hopefully everybody can see. From this point on, it's just going to be a bunch of words anyway, so it's not that crucial that you see the PowerPoint presentation. So let me get to. There, okay, so back to CyVerse basics. So the first key to doing any of the things that I'm gonna show you today is to have a CyVerse account. So you go to user.cyverse.org, you sign up, and if anyone has problems with that, just be aware that what happens is after you sign up, we send you a verification email. It's an automated system. Often that verification email ends up in people's spam folders and they don't see it and they don't understand why they can't access their CyVerse account. So if you signed up and you haven't got a notification, please check your spam folder. And if you still don't have it, contact support@cyverse.org and we can resend you that email. So once you've got that account, you can upload, download, and organize CyVerse on data. So I'm going to go over how we do that. You can share data with collaborators. You can add and edit CyVerse metadata, and there's actually 3 different ways to do that. I will demonstrate 2 of them, and the 3rd one I'll just show you so you're aware of it. And then I'm going to talk about using and creating metadata templates. So in terms of uploading and downloading and organizing your data, I hope that it's a fairly straightforward process. The complication comes with the fact that perhaps that there are about 4 or 5 different ways to do it. And if you would like to learn all of those different ways, please go to the CyVerse Data Store guide on Read the Docs. That's available through learning.cyverse.org, or you can click on this link here directly, and it will show you all of the different ways that you can access the CyVerse Data Store. The easiest way to do it, which is what I'm going to demo, is using the CyVerse Discovery environment, and so that's just de.cyverse.org. And here is a link to the quick start guide for the Discovery environment. So what I'll do is just demonstrate upload and download via the DE and I commands, and then how to create a folder within the Discovery environment. And then if anyone is following along, this would be the opportunity. If you're watching the video and you're doing this later on, just maybe hit pause for a second, and then you can practice doing this yourself. But I think, again, hopefully this is fairly easy and will not be problematic for anyone. So get back to that. Okay, so I will, I have a couple of more slides. Sorry. So first we're going to talk about, no, we're not, we're going to do the data store guide first. So let me go to the Discovery environment, which I have open here. So again, I said it's de.cyverse.org. And when you first go here, you're going to be asked to log in. If it's your first time using it, you will leave the site and be asked to authenticate a second time, and that's just to access some of our web services for certain applications. So please, if it's your first time, do that second authentication, and it'll bring you right back to the Discovery environment. So once you're there, when you've launched the DE, it's actually good. If it's your first time, it will take you through some basic tips and practices. And then you will see that we've got 3 different panes. We've got a data window, an apps window, and an analyses window. I'm going to be really focusing today on the data window. Apps is where you can launch applications to do analyses, and analyses is where you will see the results and all of the provenance history of your analyses is stored. But today we're going to focus on data, so I'll click on the data window, and it'll take you here, and you'll see a couple of different things. You'll see a folder. The top of it will have your username. Mine is rwalls. Yours will be whatever you've specified. Community data is where all of our publicly available data is, so that would include the PIRE-EHT data is here. I forget exactly what the top folder is called. Not PIRE, so I don't see it there.
It's probably just EHT.
EHT, thanks. Okay, yep, so there it is. So this is where all that EHT data is stored, you can see. And then also the data that we publish that's available with DOIs is under this, it has its own website, which is the datacommons.cyverse.org, but it's also available through the DE under this curated folder. So this is all of our published data with DOIs. But you'll mostly be, and then just also notice this tab here, it says shared with me. So anyone who shared a file with you, you can look for it here underneath shared with me and look for the username. So these are the usernames of different people that have shared data with me, including sometimes people have made data public, so it's shared with everyone, so you see a lot there. But let's concentrate on our own private data. When you upload data to CyVerse, it's stored in your own private directory by default. So here's my home directory. You can see that I've been using CyVerse for a long time, so I have many folders and files in here. But it's very straightforward to create a new file, so I can just do File, New Folder. And I'll call it 000, so it's right at the top. And there it is. There's my new folder. And if I want to put some data in there, I can use the simple upload button, simple upload from desktop, choose a file. I can go anywhere. It's on my desktop. I'll do my rental car agreement. There we go. And just hit upload. So as long as the file is less than 2 gigabytes, this method works well. If you're doing files that are larger than 2 gigabytes, then I suggest that you use one of the other methods, probably I commands, which I will show you in a minute. And so now where's the file? I don't see it, just hit refresh. And that's the file that I uploaded. So uploading is easy, downloading is equally easy. Just put a click on the box next to it, hit download, simple download, and boom, there it's downloaded, it's waiting, and it's done. So I can close that window. If I would like to share this document with collaborators, all I have to do is click, you see these three little dots? This is like the secret menu to all kinds of cool things that you can do with your files. So I could add it to my list of favorites. I could create a public link for it. I can add metadata to it, put a comment on it, copy the path to it, or as I said, I can share it with my collaborators. So right now, all I have to do is go down here, I search for a name, and I can share it with my colleague, Tyson. There's a bunch of different Tysons, so I'm going to share with Tyson Sputman at the University of Arizona. And you see by default it's giving him read permission, so he can read that file, but I can also allow him permission to write it or to be the owner. And if he's the owner, that means that he's allowed to rename that file and delete it. So you should be very careful when you share someone with someone if you give them own permission, because that means they will be able to delete your file. So generally it's best in shared projects to have one person be the owner for the whole project and give others write permission as needed. So I'll cancel this. I don't really get to share this with Tyson, but you can see how to do that. So I think we have a fairly small group here. And so we could, I don't know if we want to stop. If people want to try this, feel free to like follow along and do this with me. Otherwise, I think since it's a smallish group, what I'm gonna do is just leave a few seconds for each demo for people to do, and then people can go back and watch the recording and just hit pause as they want if they need more time to practice these skills. Though again, if you're having problems or anything, I can see the chat now, so please put questions in the chat if you need to. Okay, so that's uploading, downloading, and sharing, and creating a folder. So I hope that seemed as easy to all of you as it was to me. And we've done some uploading and sharing via the Discovery environment. So I will actually very quickly show you another way to get data into CyVerse. And if you're working on the command line, this is used to working on the command line, then this is the method that you're probably going to want to use by default, just because it's there and you can build it into scripts. And it's also very fast. It allows you to do really fast parallel transfers. And you can do, for example, you can use ibun, which is a command that bundles a file and bundles a directory, zips it up, loads it into CyVerse, and then unzips it for you, for example. So this is a tool called iCommands. As I mentioned earlier, very briefly, our data stored on the back end is powered by something called iRODS. And so iCommands is a command line interface for interacting with iRODS-based data stores. So when iCommands, if you're using it with CyVerse, you first have to install it and provide some parameters, and those are all described very clearly here in this, this data store guide. I'm not going to have everyone do that, and I'm going to do it today. But once you've got it installed, you just type init, and that initializes it, and that will ask you for your CyVerse password. And now I'm logged in. And so using if you're familiar with the command line, just basically put I in front of everything, and it's the same thing. There's a few additional commands. So for example, to see where I am, I can do ipwd. And you can see that I'm in the directory. I was playing around with this yesterday. So normally by default, you would end up in your home directory, but I've already moved into this A123 directory. I can move, I can do icd ... Then I'm back ipwd, then now I'm in my home directory. So I can do an icd, go back to A123. So now I'm back to A123, then I can do like an ls command, but I put I in front of it. So let's see what I've got there. I've got this list of files, etc. So uploading and downloading with iCommands is very similar to things that you would do on the command line, so you just use a get and a put. So if I want to download this file 012.txt, I would just do iget. So let me see, where am I on my home computer? I'm in my root directory, so I can just do a pwd and see where I am. I'm in my home directory on my local computer. So I do iget .012.txt, and that's going to download that file into my local directory, so I can do an ls. And you can see I have lots of cruft in my home directory, but right at the very beginning there is 012. And you can see now I've got that listed. So that's how simple downloading is. Uploading is the same way. You just make sure that you're either in the folder that you want to, or you specify the full path, and you do an I-put command from your local machine to iRODS. And you can do that if a lot of HPC systems will install I commands for you. So you could do that from the HPC system to move things onto CyVerse that way as well. Okay, so that's moving data in and out of CyVerse. Get rid of this here. Then we'll talk about metadata, adding and editing metadata 3 ways. So there are 3, CyVerse is a little bit confusing. You know, the whole Lego blocks thing is a great analogy, but there are times when it kind of bites you a little bit in the sense that there's so many blocks that if you don't know how to put them together, it can feel a little bit overwhelming. So that's why we're here, to try to help you figure that out. But we do, as a result of that, we currently have 3 different metadata systems. So the discovery environment, which I've been showing it, is connected to our data store, and that's our main metadata repository. We have a very sophisticated and advanced metadata feature there, which we've custom built on top of iRODS to allow us to store nested metadata, hierarchical metadata, metadata that links to ontologies, et cetera, because the built-in iRODS metadata does allow you to do that. On the other hand, the iRODS metadata, which is built into the iRODS system, is really convenient because you can use I commands. You can do something, type something called imeta to add metadata. And so that can be very useful as well. So there are uses for both of those. Finally, BISC, well, I should be showing you pictures. This is the CyVerse metadata here. Just looking at some user metadata, you can see it's got attribute, value, and unit. In BISC, on the other hand, is our image management platform. And I think since many of you probably work with image data, this may be relevant for some of you. So I mentioned it briefly. But if you end up using BISC, BISC also has its own really sophisticated linked data approach to metadata. And they've got a metadata base that looks kind of similar to what we've got in the discovery environment. So again, probably most of you won't be using that, but I just want you to be aware of that's there. No, and that is really, so the question is that, are these 3 metadata systems synced automatically? And they're not. And there's some serious technological hurdles to us doing that. And that's why, so the BISC system, BISC is a fairly separate system from CyVerse. So even though the BISC data is stored, if you go into the BISC user interface and upload data, it's stored on the CyVerse Data Store. But they have their own data index, and that's not linked to ours. iRODS and the DE metadata are both sitting here at CyVerse and the same place, so they're more connected. Both iRODS and DE metadata are visible from the discovery environment. Both of them are indexed in Elasticsearch, so you can search on them. But doing the basic CyVerse search on BIT will not return BISC metadata results. Unfortunately, it will only return the DE and iRODS metadata. Like I said, both of them are visible in the discovery environment. Unfortunately, only the iRODS metadata is searchable via I commands. So you can't view DE metadata while using I commands. So if you really want if you need the most powerful and sophisticated metadata, the DE is the way to go. And we actually we are just in the process of making our DE API live so that you can actually have command line access to that metadata as well. It's been about possible for some time, but it's been on sort of a case-by-case basis. So if that's something people need to do, we can work with you on getting that set up. So again, I've actually written a short little guide. I'm sorry, I don't have a link to it here. I'll try to find that and send the link on later to for the workshop participants. I've written a little guide on how do you know which metadata system to use in which situation. So generally we steer people towards the DE metadata, but there are a lot of use cases in which the iRODS metadata is also useful. And if you're doing strictly image-based projects, then the BISC metadata might be the way to go. And so here's an example of the iRODS metadata. Again, it's, we go into iRODS, let me see if I can make this a little bit bigger. So I do imeta h, and you can see this tells you basically you type, imeta with some options if you want, and then the command. So in order to add a new metadata object, I would do iMeta add, and so this is what I did yesterday actually here, so you can see this. I can actually bring this to the front, and I didn't copy it. So basically I wanted to add this attribute where the color was red to a file that was called 012.txt. So let me do the same thing to the file 123.txt. So I'll do iMeta add dash, let me go back to help make sure I get it right, D, and then I always forget the order in which I need to do things. So the name and then the attribute. So iMeta and then D, just to say that it's a data object, and then the file name was 123.txt, and then the attribute is color, and the value is red. And I could add a unit there if I wanted to as well, but I don't have a unit for colors. Oh, I wrote value red, sorry. Okay, so now I've just added some metadata to this file called 123.txt.color. So we can go into our directory here, go back to that first. And we've got 0, this is the file here, you see 123.txt, edit view metadata, and well, it's not there. Where did it go? Well, as I was saying, we have, this is the discovery of the DE metadata, but we've also got iRODS metadata, and that shows up under this additional metadata tab because they are separate systems. And here you can see the color red is showing up as that. So once we've added the metadata, whether we've added it here in as iRODS metadata or as user metadata, it gets automatically ingested into our Elasticsearch index, and you can search it. And so I can search for, I will say that it happens automatically, but not instantaneously. So I could actually do a search right now for things that have color red, and you will see the one that I added it to yesterday, but not the one that I just added it to because the index hasn't updated yet. So let me show you how to do a search for metadata. So just click on this little magnifying glass. You could also do quick searches by just typing, I could just type red in here and do a quick search. But what's going to happen? You can probably guess what's going to happen. I'm going to come up with thousands, 5,000, over 5,000 results, because anything that has not only metadata, but also the letters RED in the title is going to show up. So that's way too much, and it doesn't help me. So let me do a more advanced search. So I click on this, and you see I can do any or all. So this allows us to group different, have different Boolean operators to group our search criteria. So I'll hit a plus, and by default it says found name, but I can search on the owner, the path, the date created, the date modified, any tags that have been added. Tags are like metadata, but they're just single words you can add. The file size, the metadata version. So we're going to look at metadata search. And I want to say it has the attribute color and the value red. I think I might have hit it. Yeah, okay. And do search. And as I predict, as I said, it only returns to me the results for the 012.txt that I added yesterday, because it hasn't indexed the other one, the other file in which I've added which I just added to, which was the 123.txt. But if you search that tomorrow, that would show. If I search it tomorrow, it would show up. If you search it tomorrow, it won't show up, and that's because this is my private file. So when you do search results, it only returns the results for files that you have access to. So it's going to return the results for all of your private files, plus everything that's publicly accessible that you can see. And so I would like to have this moment that I think the next activity on the, back to the slideshow, make sure I'm not getting out of order here. So yeah, so I just demoed how to do this metadata with using the discovery environment and iCommands, and I would like to have this moment to give everyone the opportunity to add some metadata in the DE and to search based on metadata. And again, as I said, I'm not actually going to wait, because we have such a small group, I'm not going to wait for everyone to do it, but please feel free to go ahead and do it if you're listening right now, or if you're watching it on the video, please hit pause and spend a minute or two and try to do that. And hopefully it will work for you. And if it doesn't work, go back to those guides that I linked to in the earlier slide, and they're step-by-step instructions for everything. So the last thing that I wanted to show you was using and creating metadata templates. So actually, before I do this, I do want to say one more thing. I'm going to go back to adding metadata. And I'm just going to reiterate the point I made earlier, which is in terms of searching on metadata. So I did go on and on a little bit about how if instead of having everything organized by folder hierarchies and file names, you put metadata on everything, you would be able to organize it however you want on the fly. And that's how this works. So when you do the search, you see I can hit the save button. So what I could do here is if I had metadata, if I had a very large data project and I had applied metadata to everything, and I will just pause and say also, you don't have to do this all manually. This can all be done. We have bulk upload processes. You can upload a spreadsheet and apply metadata to thousands of files at one time. So you can do this quickly. And you can do it via API as well. So if I had metadata on my files, I could set up a fairly complex query here where metadata is the color red and metadata is the type indica. And I could sort, indica. And these are just examples that I've made up. These are biology examples. And then I can do that search and get the results, but I can also save that search and give it a name for later. And then it's kind of like smart folders if you've ever used those on your desktop. It basically allows you to have access to those searches, and it will update every time you run that search. It will update it if you add new data. So this is the way in which you can, on the fly, generate collections of files that just match the selected metadata criteria that you want. And so to me, that's where the real value in metadata lies. So I'll just quickly talk then a little bit about templates. So it does help in large projects to have templates applied to your metadata so that you can consistently, so across the whole project, so that everybody can apply the same metadata. And when we use templates in CyVerse, we can think of them as sort of a view on top of the metadata. So we store all of the attribute value unit sets of metadata in our database independently. And then when we say apply a template, it basically goes out and picks all of the fields that match the values in that template. And this allows you, if you have the same value in multiple templates, it allows you to see those. You can apply multiple templates to the same thing without having to enter the metadata multiple times. So let me just show you an example of what that means. So I'm going to go into some public data that I have, and I'm going to try to finish up here in the next couple of minutes. So we're getting to the end of the time here. So let me go down to community data and curated, and I'll show you one of the newer ones. So a recent data set, I think we'll see this on this one. So edit view metadata. And so you can see I've got fields like creator and publisher and subject. And this is just the metadata being stored in a basic way. But when I view a template, I can select template, and I can use this DOI request template. And what it does is it goes in and says, there's already values that match these things. There's a title, and so here it plugs in the title. It plugs in the creator and their affiliation and their identifier, et cetera. And so I don't have to type this metadata into the, but you can also I could go into this template and start typing here. I could choose a different type of resource, et cetera. I don't want to edit this one. But the templates allow people through this visual form to actually add. You can give them predefined lists. You can give them different types of yes, no values. You can see how we've nested metadata so that, for example, the affiliation is metadata about the metadata for the creator, their affiliation and their name identifier. And so I'm not actually going to demo how to make these templates because at the moment, this is not something that CyVerse users can do. They can only be created by data curators. But I'll say that we can make custom templates for different projects, and we're happy to do that. So if there's a need for a template within the EHT project, then basically all you would need to supply me with is a kind of a spreadsheet or a description of what the field should be, how they would be defined, and how they should be structured. And I can set up a custom template for you. So I'm going to close that without making any changes. Let me just say, then let me just see if this will work. If I apply this other template. I was going to show you how the title would automatically fill, but we haven't. But unfortunately, one of them requires title with a capital T, and one of them requires title with a small t. So it doesn't work. And so this is some of the current limitations of metadata system. And we're working on actually a new system that will map across fields so that our templates will be smart enough to know that capital with a large T and capital with a small t mean the same thing, and it would automatically fill in that metadata that was already there. And so with that, I'm going to wrap up. We're right close to the top of the hour, and I think there's time maybe for 1 or 2 questions if people would like to ask something in the chat, or I think you can speak too.
There is a question in the chat. Can you see that?
About the metadata system synced?
Yes.
I think I answered that one. I saw that one was coming in, and so I'm pretty sure. CK, if I haven't addressed that fully, let me know.
You addressed that. Thank you very much.
All right, you're welcome.
So, are there any other questions?
So I do have a few questions, but I also know we are running out of time. So I guess I will just contact you after the webinar.
You're on our floor sometimes, right?
Yeah.
Yeah. So please feel free to just stop by my office if you'd like, or ping me on Slack, and we can set up a time to talk.
Okay. Wonderful.
Okay. And yes, thank you Rosie for remembering to put the link here. This is the link. So please do take the evaluation survey. If you've watched this live or you're watching the recording, the survey will help us determine whether or not the webinar was useful and did what it was supposed to do. So
perfect. Well, since we are at time, I would like to thank Ramona for providing this webinar. It was very helpful, and I will mention to all participants that we plan to do a follow-up full hackathon so that we can actually put some of these practices and skills into use, and also work with the iRODS system. And that has not been scheduled, but it will be announced on the PIRE website in the next couple weeks. And then if I can just ask everyone to do the webinar, the webinar survey, that will help us continue to improve what we offer. Thank you, Ramona, and thanks everyone for participating today.
Thank you all. Bye-bye.
Bye-bye.
Thank you very much. Bye-bye.
Rosie, should I just sign off? Do I need to do anything else to finish up?
You don't. You can just click off.
Okay.